So hello guys, this is our final video. In this video we are talking about Apache Spark, Delta, Iceberg, Azure Orchestra and Azure AD means in the Azure ADF or Databricks and data modeling concept, real questions and some hands-on questions. So let's go with first question. First question section, Apache Spark. First question, explain Spark architecture, driver, executor and cluster manager. Spark has masters worker model. The driver plan the work, executor do the work and the cluster manager allocate resources. Means Spark has three components. First, driver is the brain. It turn your Spark code, create DAG and schedule tasks. Executor are worker. They run the actual task and store cache data. The cluster manager like Yarn and Databricks and self-hosted, those allocate the resources to the executor. Driver plans, executor execute, cluster manager allocate. Spark is distributed computer engine built on this three-tier model. Don't say driver executor the code on the worker. The driver run your application logic and executor schedule the task. It does not run transformation itself. Second question, RDD versus data frame versus dataset. When would you use RDD? RDD means resilient distributed dataset. Is a low level distributed data structure in Spark. Low level in the sense we have to move manual to the transmissions, like you can control all these transitions. It required more effort. While data frame and datasets are high level API optimizer, usually using criteria optimizer and tungsten memory management for free, making it 10 to 100x faster. High level API means easier optimizer but less gradual control. In my project we mostly use data frame because they provide better performance and easier deployment. Note, don't say dataset is available in Python. In PySpark you only use RDD and data frame. Dataset is Scala or Java concept. Third question, what is lazy evolution and why it is important? Spark does not execute transformation immediately. It build execution plan means tag and execute only when action is triggered. Transformation like select, filter, join, map, distinct, union, count, group by, etc. Actions like collect, first, show, save as text, pass, write dot parquet, for each, count, etc. This is the powerful because Spark can see your pipeline entirely and before running it and apply transformations like pushing filter before join and skip columns you never use. In my ingestion pipeline, this meant Spark could push partition filter all the way to the Iceberg scan, avoiding full tables read. Note, don't confuse lazy with slow. Lazy evolution makes Spark faster, not slower. It enables global optimization. So this is the all the lazy evolution like Spark read dot parquet filter with column drop duplicates. Now after that we are calling the action command like df dot write to this database table and append this is action. So next question is what narrow transformation versus wide transformation. Narrow transformation, each output partition is dependent on each input partition. No data movement across the network means executors. Example, filter, select, map with column, union, college. Wide transformation, each output partition is dependent on multiple input partitions. A required data movement across the network. It creates stage boundary in the DAG. It is expensive. Examples are group by, union, join, distinct, partition, order by. In my pipeline, I optimize wide transformation by using broadcast join for small reference tables. This eliminates the shuffle entirely for those joins and save one of the reason I got 30% reduction in execution time. Fifth question, what is shuffle and why it is expensive? Shuffle means redistribute data across the executor over the network, involves in disk IO, network transfer and serialization. The shuffle happen during wide transformation, likely group by or short merge join. Spark need to send raw with the same key to the same executor, so data is returned to the disk on the mapper side. transfer over the network, and read only the reducer size. Again, shuffle redistribute data across the executor over the network, involves disk IO transfer over the network, and serialization. Shuffle happen during Y transformation like group by or short merge join. Spark need to send rows with same key to the same executor. Spark need to send rows with same key and to same executor. So data is written to the disk on the mapper side, transfer over the network, and read on the reducer side. It is expensive of three reasons. Input, disk input output means shuffle file is written to the disk. Next, network transfer means all to all communication, and third is serialization. Data must be converted into bytes for transfer. In my pipeline, I always check the Spark UI shuffle read write matrix. When I saw shuffle on the reference table join, I switched to broadcast join, which drop shuffle to near zero. Don't say shuffle always mean data is sorted. Shuffle just redistribute data, not sorting. Sorting is separate step in sort merge join. Question number 6. Question number 6. Join job, stage, and task. Task means one action, stage means group of the task with the no shuffle, and task means group of the task with the no shuffle, and task means one partition processed by one executor core. Every time you call the action like count or write, Spark creates a job for each action. Each job is split into the stages. A stage is a group of the transformation that can run without shuffle between them. Each stage is split into tasks. One task process one partition. If you have 200 partition, a stage have 200 tasks running in parallel. In my project Spark UI, I had a look at stage review. If one task tool 10x longer than other, that was a data skew signal. Note that don't say one job has one stage. A single group by dot count already create two stages, one before shuffle and one after. Question number 7. Repartition versus collage. When to use each. Repartition means increase and decrease the partition. Always shuffle. It reduces the data evenly across the partition using round robin and hash method. Collage only decrease the partition. Avoid shuffle by merging them into same executor much cheaper. In my pipeline, I use collage before writing Iceberg file to reduce the number of input files. I use repartition when I need to increase parallelism before heavy with group by or when data is skewed. Use collage to reduce file size before write. Use partition when you need balanced parallelism more partitioned. And again there is another point, partition by. So they will ask you difference about repartition and partition by. Partition by, it is create directory based stage partition on disk. It determines the folder layout of the output file. It is for query performance and partition running. This is the command repartition in bracket 5 dot write dot partition by code. In that repartition control how many files are created inside each date folder. Then 8th question is cache versus persist storage level. Both cache and persist are used to store data frame, Spark data frame or DD in memory. It is a part of the executive memory so that a repeated computation become faster. The main difference between two are cache store data in only memory by default, while persist it allows different storage level like memory, disk or both. In real project, I usually use persist memory on disk for large dataset because if memory become full, Spark can split remaining data into the disk safely. If we use cache incorrectly on very large dataset, executor may run out of memory causing garbage collection, overhead, spilling, slow performance, or even job failure due to out of memory error. So before caching, you should verify that dataset is reused multiple times and is small enough to fit efficiently in cluster memory. This is the commands catch df.catch df percent bracket storage level dot memory only, memory and disk, memory and disk, yes, memory and disk. And after that, after using, we have to unpersist data using df.unpersist bracket complete. Then 9 question AQE. AQE means adaptive query execution. Spark is a AQE is a Spark 3 feature that re-optimize the plan after each shuffle stage using real-time statistics. It does three things. First, collage the empty partition. Shuffle partition means if you are using only 15 partition, remaining default are 200, okay, and we are using only 15, other 15 are only empty. So AQE will analyze that, and it will do the we will not need to run 185 empty tasks. Then convert short merge join into a worker join. If it is discovered one side is small, then we can do that. Split skew partition automatically. I always enable AQE in my database pipeline. I was especially useful in my project where some joins had moderate skew. AQE handle it without any code changes. Spark AQE will initiate the split if only both threshold are broken. Don't say AQE fix all skew. For example, extreme queue, only one key is equal to 100% of data. AQE may not be enough. Manual sorting is still needed. Enable AQE by default on from Spark 3.2. Spark.sql.adaptive.enable, true. Spark.sql.adaptive.collage partition.enable, true. And for enable Spark skew partition, you have to run spark.sql.adaptive.sqjoin.enable, then sqjoin.skew partition factor is equal to 10. By default is 10, but 10 is partition can be split into up to 10 smaller tasks. Then spark.sql.adaptive.sqjoin.skewed partition threshold in bytes is 256 MB. Means any partition larger than 256 MB is considered as a skew. Then 10 question is broadcast join. When to use it? In broadcast join Spark. In broadcast join Spark copy the entire small table to each executor, then join it locally partition of large table with that local copy. Due to that, no shuffle happen. Use it when table is fit in the executor memory. Size is 10 to 100 MB. In my project, my reference table XRF mapping facility code drug lookup table were all under 200 MB. I broadcast those in every join, which eliminates few shuffle stage and contribute to my 30% performance gain. Note that if does not broadcast large table, broadcasting 500 MB table will out of memory every executor. Always verify the actual table size before broadcasting. From spark.sql.functions import broadcast. Then df is result is equal to df dot join in bracket broadcast in bracket df underscore small bracket complete. Then on condition, then how, means which we are going to use. Then next question is dynamic partition pruning. Dynamic partition pruning is a optimized where Spark uses the result of the one side of the join, typically small dimension table, to filter partition in the large fact table at runtime before reading them. Without DPP, Spark read all partition of the table, large table, then join. With DPP, Spark first evaluate the dimension filter. Use those values to tune which partition of the fact table to scan. My iceberg table where partition by load date and region. When I downstream the query is on region, means US, DPP ensures Spark only open that relevant iceberg manifest file and Parquet data file, critical for your 220 TB terabytes of performance. Enable DPP. Spark.sql.set in bracket spark.sql.optimizer.dynamic partition pruning .enable, true. How we can use that? Result is equal to patient underscore df dot join in bracket territory underscore df dot filter region is equal to US, comma, on condition territory ID. Note that DPP only work when the large table is physically partitioned on disk and join or filter column match the partition column. DPP not always trigger. DPP trigger only when it fit cost beneficial. Next question is, what is data skew and how to handle it. Data skew is a one partition has more data than other partition, causing one slow stageable task means slow running task that delay the completion of the entire Spark stage. Skew happen when one key like top customer ID has millions of rows while other have 100 rows. The partition take 100x longer time than others and hold up to entire stage. 3 solutions: broadcast join, join, manual sorting. In broadcast join, if the other table is small, broadcast it and keep shuffle entirely. Skew join, Spark 3 auto split skew partition at runtime. Manual sorting, add random sort column to the join key to distribute skew rows across multiple partitions. At every one facility ID had to 40% of all records. I use broadcast join for reference table, which eliminate the skew completely. Skew is most common Spark performance problem. Detect it in Spark UI event timeline. Fix it with broadcast, AQE, and sorting. Note that don't use repartition to fix skew. If some key dominates repartition on the key, map all row back to the same partitioner. Skew remain. 14th number question. Spark fault tolerance. How does Spark handle fault tolerance? Spark track every transformation in DAC called lineage. If executor fail or lost the partition, Spark rerun that partition from last table point and enable either source or checkpoint. Task failure try up to 4 times by default. In my Databricks pipeline, I set checkpoint for long running job and use merge operations so rerun are safe. Lineage is Spark fault tolerance mechanism. Don't lost data is recomputed and not restored from the replica. Note that does not confuse Spark fault tolerance with HDFS replication. Spark does not replicate data by default. It recomputed from lineage. Configuration task retry. Spark.config.set in bracket spark.task.max failures, 4. For streaming exactly one with checkpoint, df is equal query is equal to stream df dot write stream dot option checkpoint location, S3 path, then dot start. Question number 14. Explain Catalyst Optimizer. Catalyst Optimizer is a Spark query performance that transfer your logic into most efficient physical logic execution plan. There are 4 steps. First, it check your code into logical plan, validate columns, types, functions against the catalog. Optimize the logical plan means apply rule-based optimization like filter or predicted push down means row filter rows, projection push down means select only needed columns, and constant folding. When it generates multiple physical plans and apply cost optimization code, pick the cheapest one. Then it generate multiple physical plans and apply cost-based optimization and then pick the cheapest one. Consider row count join strategy. Then generate bytecode via tungsten and that executes as the tight Java loop. Catalyst is why data frame are faster than RDS. It optimizes global across your entire pipeline before single task run. Note: don't say Catalyst only does filter push down. It also handles projection push down, join, reordering, and constant folding. All critical optimization. Then 15 question. What is tungsten and how does it help in performance? Tungsten is a spark execution engine focused on CPU and memory efficiency. And tungsten remove the JVM overhead from spark. Off-peak memory plus code generation, it makes near native speed. Note, don't confuse catalyst with tungsten. Catalyst optimizer the query plan means how to do, and tungsten optimization is optimize execution how to do it fast, and what, and catalyst optimizer plan what to do, and tungsten optimizer execution how to do it in fast. Question number 16. Checkpoint versus caching versus persistence. Checkpoint means memory storage and lineage preserve. Caching means memory store and lineage preserve. Checkpoint means disk storage lineage broken. Persist means configurable storage level. Cache means store data in memory split to disk. Persist is same, but you can choose the storage level like memory only, disk only, or both. Both preserve the lineage. If data lost, Spark recompute it from the source. Checkpoint is different. It write to the stable storage like S3 or HDFS or HDFS and cut the lineage. If data is lost, it recover from the checkpoint, not from the source. Use it for long lineage chain or streaming job. In my pipeline, I always use checkpoint location on S3 so job can resume from last offset after failure. Cache for reuse, checkpoint for fault tolerance in long running and streaming job. Note, don't use checkpoint for regular batch data frame reuse. Caching is cheaper and faster. dev.cache, dev.persist in bracket storage level dot memory and disk, and for checkpoint dev.checkpoint. Before that we have to use spark.context dot set checkpoint dir. In bracket we have to give the S3 path. Then we can use dev.checkpoint. 17 question. A slow Spark job. How do you diagnose? Open the Spark UI, then find out the slow stage. Check for skew, shuffle, size, and input-output bottleneck. Fix the root cause. My first step-by-step approach is first I will open Spark UI, then find out slow stage. Find out the slow stage. Then look at the event timeline. If one task bar is much longer than other, it data skew. Check shuffle read write size. High shuffle means too many white transformation. Then I run explain format to check the physical plan. Look for unnecessary exchange operator shuffle. Short merge join on small table should be broadcast, and whether DPP is active. At my project or at FV, I downloaded 40-minute job that was doing short merge join on 5 MB reference table, switching to the broadcast join, drop it to 8 minutes. Don't just go through more resources, give more resources as slow job. Always download first. Adding resources won't fix data skew or unnecessary shuffle. Question number 18. Explain Spark memory management. Basically, we have like a Spark split executive memory into execution memory, shuffle, short join, and storage memory, cache and broadcast. Both share unified pool in Spark 2. Spark executive memory has two main regions: executive memory and storage memory. Executive memory handle active operations, shuffle buffer, sort buffer, join hash table. Storage memory hold cache data frame and broadcast variable. In Spark 2 Plus, they share unified pool. Execution can borrow from storage and vice versa. If storage memory is full, it's split to the disk. You will see this high split in the Spark UI. When I saw memory split in my jobs, I increased Spark.executive.memory and reduced the shuffle of partitions. Spark.sql.shuffle.partitions. So each partition was smaller, less memory pressure per task. Summary: split to disk means out of memory is approaching. Tune executive memory and partition count before it become the job failure. Note: don't set Spark executor memory too high. Leave 10-15% of OS overhead, otherwise the executor get killed by the OS. Question number 19. Cluster mode versus client mode. Cluster mode run on your machine. Client mode driver run on your machine. Cluster mode driver run inside the cluster. In client mode, the driver runs on the machine submitting the job. If you disconnected, job fail. This is good for interactive notebook in Databricks. Cluster mode. The driver run on worker node inside the cluster. The job continue even if you disconnect. Ideal for production batch job. In Databricks interactive notebook use client mode by default. Might ADF trigger production job run in cluster mode so they are not affected by machine connectivity. Client mode for development, cluster mode for production. Always use cluster mode for schedule job. Note: don't run long production job in client mode. If the connection drop, the major job fail. Enter job fail. Then talk about last question 20 for Apache Spark. UDF, why expensive and alternative? UDF, Python UDF breaks tungsten optimization, required JVM to Python serialization for every row and run row by row. My project work like in my project, I replace several Python UDF with when otherwise chain. Same logic but 5 to 10x faster. If you compress it with native Spark function, never you write UDF, Catalyst cannot optimize black box. Note: don't use regular Python UDF for anything performance critical. Always check if a native function exists first. So this is a 21 question. What is Apache Spark and why which we can choose it? You have to choose it. Apache Spark is an open table format for data that add feature like acidic transitions, time travel, schema evolution, and partition evolution on the top of Parquet file stored in data lake like S3 and LS Gen 2. In our project, we use Spark and Hive with Iceberg table. Apache helps us manage large-scale healthcare data effectively while maintaining data consistency and reliability. We choose Iceberg because it support hidden partitioning, schema change without rewriting data, and better metadata management compared to transitional Hive tables. Basically, Iceberg bring data warehouse reliability, acidic transition, schema evolution, and time travel to an open data lake architecture. Note: Iceberg does not replace Parquet files. Iceberg uses Parquet, ORC or RO as the underlying files format and add metadata layer on the top of it. Next question: Iceberg table architecture. Metadata manifest list manifest file data files. Iceberg has 4-layer metadata architecture: metadata files, manifest list, manifest files, actual Parquet data files. Iceberg has layer metadata architecture. At the top of the metadata layer files, it points to the current snapshot. The snapshot points to the manifest list, a list of the all manifest files. Each manifest file containing set of the Parquet file data files and store column level statistics min max. The actual data file are at the bottom. The structure means Iceberg skip file without scanning them using column state from manifest files. No directory listing needed. Iceberg metadata hierarchy enable file level skipping. It knows exactly which file contains your data without scanning everything. Note: don't confuse manifest list with manifest file. Manifest list is the index of manifest file, and each manifest file track actual data file. Flow metadata flow: manifest file, then manifest list, manifest files, metadata files, manifest list, then manifest files, then actual Parquet data files. Next question is 24. What hidden partitioning in Apache Iceberg and how does it different from traditional Hive partitioning? Hidden partitioning lets Iceberg driver means take partition value from column transform, no extra column needed in the data, no change needed in the query. In high style partitioning, you add a physical column like event date and query must filter on that exact column name. In Iceberg, hidden partitioning use transform like day of event underscore ts comma bucket in bracket 16 comma user id. Iceberg drives the partition value from timestamp automatically. Again, hidden partition lets Iceberg take partition value from the column transform. No extra column needed in the data, no change needed in the query. In Hive style partitioning, you add a physical column like event date and query must filter on that exact column name. In Iceberg, hidden partitioning uses transform like day of event days and bracket 16 comma id user id. Iceberg drive the partition value from timestamp automatically. So when I query filter where event is between 2011 and 2044 1 January 2044 31st Jan, Iceberg automatically take only January partition without the query knowing about the partition schema. At FV, this was critical. Our 20 terabytes of dataset was partitioned by dates of record date. Query just filter on record date, and Iceberg handle tuning automatically. Hidden partitioning means partition logic lives in the table metadata, not the query. Cleaner code, automatic tuning. Note: don't add separate partition column when using Iceberg hidden partitioning. That defeats the purpose. Just use the transform. Next table is like what is partition evolution in Iceberg. Iceberg allows you to change the partition schema of the table without rewriting the existing data. In Hive, changing partitions means rewriting all existing data. In Iceberg, partition evolution is metadata only. You just update the partition space. Old files keep the old partitioning. New files use the new space. Query works transparently across both. At my project, when our data volume grow, we change from a monthly to daily partitioning on key tables. With Iceberg, this was single alter command. No 20 terabytes of rewrite needed. Partition evolution means change strategy without migration. This alone made Iceberg worth it for our 20 terabytes of dataset. No, don't try this with Delta Lake. Delta Lake does not support partition evolution. You need to rewrite the table. Change from monthly to daily partitions. Command is alter table name means replace partition field months of event dates with dates of event date. Next question 26. What is time travel in Iceberg? Pharma audit use case. How does time travel work in Iceberg? Answer: Iceberg keep the history of snapshot. You can query any previous version of the table using the timestamp or snapshot ID. Insert, update, delete. Every insert, update, delete in table, Iceberg create new snapshot. In our pharma project, this was critical for regular audits. Auditor need to see exact what the data look like at specific point in time. Note: time travel only work if you haven't run expired snapshot. Always keep the reasonable snapshot retention window for compliance needed. Query: select star from table name version as of snapshot ID 1 2 3 4. Again दूसरे with timestamp query, select star from table name timestamp as of 2024-01-01 then space 24.20 hours minute second. Then what is compaction in Iceberg? Compaction merges many files into fewer large files to improve scanning performance and reducing metadata overhead. Every write to Iceberg create new snapshot over time, especially with frequent small append. You get thousands of tiny files. Reading them is slow because Spark has to open, read and close that file for each one. Iceberg rewrite data files. Compaction merge small file into target size, typically 128 MB to 1 GB. I run compaction weekly on high write tables in our FV pipeline. Compaction is like optimized in Delta. Fix the small file problem to keep the scan performance healthy. Note: don't run compaction during peak ingestion hours. It complete for S3 input output with your pipeline. Command is call iceberg underscore catalog dot system dot table name. Call iceberg comma catalog dot system dot rewrite underscore data underscore files in bracket table is equal to farm table name, strategy is equal to blink pack, and option is equal to map in bracket table size target file size bytes, comma we have to give in the bytes, that is 128 MB, and strategy being paired because compaction strategy combines small file into larger files. Next question is 28. What is copy on write and merge on read in Apache Iceberg? In copy on write, when we update or delete records, Iceberg rewrite the entire Parquet files containing that record. Read are always faster because files are clean, but writes are expensive for high frequency update. In merge on read, updates write a small data or delete files. Read must merge base files with delta files. Slightly slower read but much faster write. In my project, our ingestion table use copy on write. We write in larger batches once daily, so rewrite cost is fine, and read are always faster for analytics. Copy on write read for read heavy analytical tables, and merge on read for write heavy CDC, means change data continuously or streaming tables. Note: don't use copy merge on read if your team run many ad hoc analytical queries. The merge on read override compounds across many queries. 29 question: how does schema enforcement versus schema evaluation work in Iceberg? Schema enforcement means it is default. Iceberg rejects write that does not match the existing table schema. It protects data quality by preventing accidental schema changes. Schema evaluation: Iceberg supports safe schema evaluation. Add, rename, drop, reorder columns without rewriting data with full backward capability. Iceberg schema evaluation is metadata only. No data rewrite needed. You can add a column, new file have its own new file have it, old file rerun null. Rename a column, track by column ID, not same name. Drop a column, it is hidden from query but still in old files. Reorder columns, save because Iceberg track by ID, not position. At every Salesforce API response, occasionally adding new field. With Iceberg, I use merge schema is equal to true and the table schema auto updated. No pipeline failure. Iceberg track columns by ID, not name. That's why I renaming and reordering are safe without breaking existing data. Appending with new column, like we can add option while writing into the Iceberg. Merge schema is comma true, and there is another option for override the schema. Option in bracket override schema comma true. Don't confuse schema evaluation with override schema. Schema evaluation means merge schema comma true, and override schema means it restructure full schema replacement. What is difference between Delta Lake versus Iceberg versus Hudi? All those Delta based for Databricks, Iceberg based for multi-engine open ecosystem, Hudi based for high frequency CDC and streaming updates. All three add acidic transitions and time travel to Delta Lakes, but they differ in strengths. Delta Lake is tightly integrated with Databricks. Best tooling for Spark DLT Unity Catalog, but has limited support outside the Databricks ecosystem. Iceberg is truly engine agnostic. Spark, Trino, Flink, Pestro all work natively. Best for multi-engine architecture and has the most advanced partitioning, means hidden partitioning and partition evolution. Hoodie is optimized for record level update and CDC. Faster return performance for high frequency streaming update. Popular at Uber for exactly this use case. When use Iceberg at every when we choose Iceberg at every because our analytics team using Tringo alongside Flink. If you are all in on Iceberg, on Databricks, use Delta. If you need multi-engine flexibility, use Iceberg. If you need fast record level upsert, use Hoodie. Note: don't say one is slightly better than others. The right choice depends on your engine, ecosystem, and right pattern. Question number 31. You need to migrate 20 terabytes of legacy dataset with zero downtime. Walk me through your migration strategy. Or if your company has very large old dataset, 20 terabytes, and want to improve it to new platform without stopping business operations, how would you do it safely? Migration 20 terabytes of data with zero downtime required a step-by-step approach. First, we create new Iceberg pipeline and run it in parallel with old Hive system. We copy historical data in batches while the old system continues serving users, so there was no business impact. Next, we validate the migration data by comparing row count sample records and compare data using SQL query between Hive and Iceberg tables to ensure data accuracy. After validation, we start processing only incremental or newly added records in Iceberg. Then we gradually redirecting downstream application and reporting pipelines from Hive to Iceberg. We kept the legacy Hive system in read-only mode for few weeks as a rollback backup before fully decommissioning it. One major challenge was partitioning. Initially, partitioning by patient ID created too many small files and increased the metadata overhead. We optimized this by partitioning using year of event dates, which improved query performance and file management significantly. Very simple summary. What are you actually doing? First, create the new Iceberg system. Copy old Hive data slowly. Keep both systems running together. Compare old and new data. Move new incoming data to Iceberg. Switch application from Hive to Iceberg. Keep old system as backup. Remove old system after stability. Note: don't migrate all table at once. Migrate one table, validate fully, then move to the next. Parallel validation across all tables is unmanageable. So next chapter is section 3, Delta Lake. What is Delta Lake and how does it differ from the plain Parquet? Delta Lake adds ACID transition, time travel, schema enforcement on the top of the Parquet files using transition log called Delta log. Plain Parquet is just a file format. No transition, no update, no history. Delta Lake add a Delta log folder alongside with the Parquet file. Every write, update, or delete create new JSON entry in that log. The log is source of truth. Reading the Delta table meaning reading the log to find which file are current. Delta give you ACID transition means all or nothing writes. Time travel means query past versions. Schema enforcement means reject bad schema and save concurrent writes. In my project where we have 10 millions of record daily with strictly auditability requirement, ACID is non-negotiable. Note: don't say Delta replace Parquet. Delta Lake use Parquet files internally it added the transition layer on the top. Asterisk in delta. How does delta log enable it? Every operation create commit entry to delta log automatically. If the commit file is there, the transition succeed. If not, it never happen. Delta achieved asterisk through its transition log. Every write create new JSON commit file in delta log. This is atomic. Either the file return completely or not at all. Atomicity. Commit file exists means success. If the job crashes in mid write, the commit file is never created. The partial data is invisible. Isolation. Readers always see the latest committed snapshot. They never see in progress write. Consistency. Schema enforcement reject. Check column which align with the table or the schema before loading into the table. They check data types, column name, table name, database name, etc. Durability. Once the commit file is on S3 or Gen 2, it's permanent, even if the cluster crashes upward. If the delta log is a backbone of delta asterisk, it is a append only ladder where every transaction is either fully recorded on the existing or does not exist. Don't say delta use database style log. Delta uses optimistic concurrency. Writers process independently and conflict resolution happen at commit time. Schema enforcement versus schema evolution in delta. Schema enforcement means it rejects write that don't match with the schema. Schema evolution allows adding new column with bar schema is equal true. In details, schema enforcement, it is a default. Delta reject any write those whose schema does not match with the table schema. This prevent accidental schema drift from breaking downstream consumers. Schema evolution, it is an option in delta. When the source add new column, you use merge schema is equal to true to get delta automatically add those columns to the schema. Schema evolution means auto add new column. Def is equal to write dot format delta dot option merge schema comma true dot mode append dot save path. In my project Salesforce API response added new field. I have used merge schema is equal to true in those pipelines, so new columns are captured without pipeline feature. Enforcement protect data integrity. Evolution handles source system changes. Use both strategically. Note: don't confuse merge schema with override schema. Merge schema add columns. Override schema completely replace the schema. Dangerous in production. Next, small file problem. Optimize and volume. Scenario: delta table suddenly becomes slow. The answer is many writes create many small packet. Optimize them. Vacuum remove the old unreferenced files. Most delta perform issue come from small files, poor partitioning, skew, or metadata growth. In details, answer is every Spark task write one file per partition. With 200 partition writely daily, you accumulate thousands of tiny files quickly, causing slow scan because Spark open each file individually. Optimize compact small files into larger ones, targeting 1 GB. Optionally with Z order by cluster edited data together. Vacuum remove Parquet data files no longer referred by the transition log. It clean up the old files from update and delete. Default rotation is 7 days to support time travel. I schedule optimize weekly and vacuum after it in our pipeline. Optimize schema.table or Z order by in bracket customer ID comma event date. Bracket complete. Vacuum schema.vacuum space schema.table retain 168 hours. Optimize for performance, vacuum for storage cost. Run them together has weekly maintenance. When data slows down, I first check small file partition pruning and shuffle heavy queries. Note, never use vacuum retention 0 hours in production. Question number 36. What is zero ordering and what is liquid clustering? Zero ordering sort data with files. Like we will go through this one. Like zero ordering is a multi-dimensional data clustering technique that collocate data within the Parquet files, so that query filtering on those columns can skip more file using min-max statistics. Again, zero ordering is a multi-dimensional data clustering technique that collocate data within the Parquet files, so that query filtering on those columns can skip more files using min-max value. So querying filtering on those columns can skip more files using the liquid clustering data is evolution. It achieves the same goal but incrementally without writing the whole table. You can also change clustering column without full write. For our current step up at my project in Databricks, I use zero ordering on high quality filter columns like patient ID, facility ID that can be partition column due to cardinal ID. Zero ordering for multi-column data skipping. Liquid clustering if you need incremental, maintainable clustering without full write. Note, don't zero order on your partition column. It is already clustered by the clustered at the folder level. Zero order on high quality columns that are not partitioned. Optimize raw.cro or zero order by ID and department. 37 question. Part pipeline accidentally detect 1500 records. How do you deleted pipeline accidentally deleted 1500 records? How do you recover using Delta? Use Delta time travel. Restore the table to the version before the deletion. So this is the exact what Delta time travel is designed for. Find the version just before bad operation. This is instance. It just update delta log pointer. No data is rewritten. Important only. This will only work if vacuum does not remove the old files. That's why I keep retention 7 days. So extract exactly this kind of production recover. First, find the version before the deletion. Describe history schema or table name. Then restore that version. Restore table name to version as of 42, like that. Or also we can run restore table schema dot table name to timestamp as of 2024 01 15 hour minute second. Don't vacuum immediately after recovering the issue. You might delete the files you need for recovery. Merge operation and CDC pipeline in Delta. Merge perform insert update delete in more atomic operation, mostly in CDC pipeline. CDC stands for change data capture, where source system send incremental change instead of full load. Delta Lake use merge on to apply those changes repeatedly. Merge into target table name TGT using stage name SRC on TGT.patient ID is equal to SRC.patient ID. When match, then update star. When not match, they insert star. Merge is the foundation of scalable CDC pipeline in Delta. This is our approach we read here. Then what is the question number 39? What is the difference between slow shadow clone and deep clone, and when would you use each? So answer shadow clone. Create a new table that pointed to the same data files as the source. No data is physically copied. The clone has its own delta log but shared a source file. Storage cost near zero. Creation time in second. Independency partial. Write to the clone diverge from source, but read still need source file. Use dev and test environment. Quickly experiment table staging. Deep clone. Copy all data files and transition log to the new location completely independent. Storage cost as same as source, full copy. Creation time proportionally data size, means dependent on data size. Uh, Independence, completely independent. Source can be deleted without affecting clone. Use production backups. Synthesis: create table, test clone, shadow clone, production table name. Create and second is deep clone. For deep clone, create table, backup underscore clone, deep clone, production table name. Real example from my work when testing new Medallion architecture refactor. I had shallow clone the production trusted layer, means silver layer, to the dev workspace. I can run experiments. The clone is free and any write I make won't affect production. But for quarterly disaster recovery backup before major migration, we had deep clone to ensure we can restore independently even if production workspace is unavailable. Section 4: Data Architecture and Modeling. Lakehouse architecture versus Delta Lakehouse versus Delta Lake versus Delta Warehouse. Delta Lake Delta Lake store new data, raw data in any format, cheaper on S3 or AWS, but no acidic, no transactions, and no guaranteed query, no history. Data Warehouse like Snowflake and Redshift has acidic query, fast query, strict schema, but expensive and does not handle unstructured data well. Delta Lakehouse combine both open format means Parquet plus Delta Iceberg on cheap object storage with warehouse level features, aesthetic schema enforcement, time travel, and SQL support. At FV, we build Lakehouse using Iceberg on S3. We get S3 storage cost with acidic and time travel for regulatory compliance. Lakehouse is equal to Delta Lake plus Data Lake versus plus Data Warehouse features. The best for both worlds. No on open storage. Don't say Lakehouse is just marketing term. It is a real architecture pattern where specific technical capability enabled by Iceberg, Delta, or Hoodie. What is Medallion architecture? There are three stages. First is raw, trusted and created. Bronze, silver, and gold. In bronze, inject data as a from source, no transaction, full history, preserve a source of the truth if anything goes wrong downstream. Silver, clean, validate, deduplicate, enforce step, apply DQ check where reject or quarantine bad records. Gold, business level aggregation, join and enrichment, optimized for consumption by analyst and ML terms. At FV, I reflected legacy SQL script into this Medallion pattern. It gives us clear data lineage, easier debugging, and regulatory auditability at each stage. Partitioning. How to choose the column for partitioning. Good partition column has those properties. First, low to medium cardinality means 10 to 10,000 values, not millions. Frequently used filters, so skipping triggers, pruning trigger. And third is event distribution, means avoid one date having 90% of date. Date column like event date or load date are ideal for time series data. Avoid high cardinality column like user ID. They create millions of tiny directories, killing metadata performance. In my project, I partition by year of event TS date as the level, combined with Z ordering on partition patient ID and facility ID for fine grained data skipping within the partition. Partition for pruning, Z order for skipping. They work at different granularity and complement each other. Note: don't partition on high cardinality columns. A user ID partition on 50 million user is equal to 50 million directory on S3. Okay. 43 question. Design a pipeline for 500 Oracle tables to Iceberg. Build metadata answer. Build metadata driven framework. Config driven integration. Not 500 separate script. You never write 500 individual script. You build metadata driven framework where config table or YAML file define each table integration rule. Source the table name, load type, full incremental, partition column, primary key, target path. The framework create this configuration and run on generic PySpark class for all tables. Configuration is equal to load config in bracket oracle underscore table dot YAML bracket complete. This is the code. This from this. Then for table in config inject. This is the inject underscore engine dot run in bracket table name. One framework for all tables. This is exactly what I built at AVI. It handles 50 million records daily across all source tables with a single deployment code base, no duplication. 15 tables equal to 1 framework, not 15 script. Metadata driven design as only scalable approach. Note: don't hardcode table name or schema in PySpark code. Any hardcode logic become maintaining my nightmare when tables change. Section number 6, Azure and orchestration. EDF versus Databricks workflow. EDF is orchestration across system, ETL, copy, trigger, schedule. Databricks workflow clusters in the Spark need to compute jobs. EDF is a Azure orchestration service. It is great for copying data between systems, triggering Databricks notebooks, scheduling pipelines, triggering with non-Spark sources. It has GUI for non-engineers. Databricks workflow. It is a code first job orchestration, and ideal when you build all your compute is Spark based. You want notebook cleaning or you need complex dependency management within Databricks. In my project, our pattern is EDF handle trigger file arrive on S3 schedule fire at 2 a.m. and then call Databricks notebook for all PySpark transformation logic. EDF great for copying data between systems, trigger Databricks pipeline schedule pipelines integrating with non-Spark source. Databricks is mainly used for data processing and transformations, while EDF is mainly used for orchestration, scheduling, and monitoring and integrating multiple sources services. EDF for orchestration, Databricks for complex Spark transformations, ADLS Gen 2 for storage, Iceberg for table. EDF trigger notebook manage the dependency between ingestion, transformation, and reporting pipeline. EDF is a orchestration and triggers EDF for Databricks for compute. Use them together, non-alternatives. No, don't try to heavy data transformation inside EDF data flow. For complex PySpark logic, always trigger Databricks notebook from EDF. 52 question. What is utility catalog and Databricks? In Databricks, what governance benefits does it provide? Unity catalog is sit above Databricks workspace level. It manages data permission, lineage, and discovery across all workspace in one place. Key feature: find gain access control, means row and column level security, data lineage, track which notebook root which table. Third, centralized audit log, who accessed what and when. I use Unity Catalog to restrict access to PHI columns. Only authorized user in the clinical team could query patient PII. Everyone else got marked value through column masking policies. Unity Catalog is equal to one governance layer for all Databricks workspace, RBAC, lineage, and audit in one place. Note: don't confuse Unity Catalog with Hive metadata. Unity Catalog is multi-workspace, multi-cloud. It is processor to workspace level high meta store. Question number 53. What is Azure Key Vault? How do you use it in Databricks for secret management? Azure Key Vault stores secret password and tokens. Databricks use secret scope by key vault to access them securely. When you never store password in code or notebook. In Databricks, you create secret scope backed by Azure Key Vault, then access secrets using Unity cat dbutils.secret.get. Like in JDBC, password is equal to dbutils.secret.get, bracket scope is equal to v-key, comma key is equal to Oracle password. Like that. The secret value is never printed or logged. Databricks redact it automatically. Key Vault also support rotation. When password change, you update it in Key Vault, and all pipelines pick it up without redeployment. Key Vault plus Databricks secret scope is equal to 0 secret in code. Security requirement not optional. Note: never hardcode credential in notebooks, even temporary. Notebooks get committed to get credentials exposed in history forever. Question number 54. What is ADLS Gen 2 and how it is differ from regular block storage? ADLS Gen 2 is Azure Enterprise Data Lake storage. It adds hierarchical system, file system, fine grain security, and big data performance. Big data performance on top of standard Azure block storage. Azure block storage is general purpose object storage, good for storing files, backup, and static assets. ADLS Gen 2 is built on top of block storage but add features specifically for big data workload. Three key differences. Hierarchy namespace HNS. Regular block storage is flat. Everything is just object within key. ADLS Gen 2 has real directories and folders like file system. This matter because operations like renaming folder are atomic and n of 1, not n of n, like in flat storage block. Fine grain access control. ADLS Gen 2 support POX. You can set permission at file level, not just container level. Regular blocks only support RBAC at the container level. Third, performance at analytics. ADLS Gen 2 is optimized for parallel read, used by Spark ADF Databricks high HDD insight natively. It supports the HBFSS :// protocol for secure access. In my project, all Databricks Delta table are stored in ADLS Gen 2. The hierarchical namespace make directory operations fast when compacting or reorganizing partitions. ADLS Gen 2 is block storage with file system brain, hierarchy namespace, and analytical grade performance. Note: don't say ADLS Gen 2 is completely separate storage service. It is block storage service with hierarchy namespace feature enabled. Same underlying features, infrastructure, upgraded capabilities. Usage: Azure block storage use case like file storage and backups. ADLS Gen 2 use case Delta Lake, Lakehouse Analytics. When would you use Azure Synapse Analytics over Databricks? Use Synapse when you need unified workspace combining SQL, data warehouse, Spark, and Power BI in one place. Use Databricks when you need advanced Spark optimization, ML workflow, or based in-class data engineering. Again, use Synapse when you need unified workspace, means combined workspace that combining SQL, data warehouse, Spark, and Power BI in one place. Use Databricks when you need advanced Spark optimization, machine learning flow, and or based in class data engineering. Both are Azure big data platform, but they serve slightly different primary use cases. Like choose Azure Synapse when your team is SQL first, analytical who prefer TSQL over PySpark. You need to dedicated SQL pool for BI workload. You need one unified workspace for SQL, PySpark pipeline, and Power BI integration. The workload is primarily constructed data reporting, not complex ML or data engineering. Choose Databricks with advanced PySpark processing and advanced optimization, large-scale ETL pipeline. You need to unified catalog for enterprise governance, Spark performance optimization. You need Delta Live tables or DLT for declarative pipeline deployment. Note: don't say one strict better because both are valid choices. The answer always depends on the requirement or team skill set, primary workload type. 56 question. CI/CD for Databricks Azure DevOps. Get branching strategy plus automated testing plus Azure DevOps pipeline. Deploy notebooks and job configuration across dev to staging to production. My CI/CD workflow. Developer work on feature branch, raise PR to into dev branch, Azure DevOps pipeline, run unity test using PyTest on merge to main, release pipeline, deploy notebooks to Databricks workspace and updates job configuration. Secrets like Databricks underscore token lives in Azure DevOps variable group linked to key vault, never in the pipeline YAML. CI/CD for Databricks is equal to automated test on PR plus automated deployment on merge. No manual notebook uploaded in production. Don't deploy notebooks manually in production. Any manual step create draft between environment and it is not reproducible. So in this 7th section we are discussing about ingestion pattern. So 57 question: what is a JDBC and how did use to it to ingestion from Oracle with parallel read? JDBC stand for Java Database Connectivity. It is a standard API used by Spark to connect and read data from relational database like Oracle SQL Server, MySQL and Postgres SQL. In our project, we use JDBC to ingest data from Oracle into Spark data frame for downstream process in Delta or Iceberg table. Code is df is equal to spark.read.format in bracket JDBC dot option in bracket URL comma JDBC dot colon Oracle colon thin thin colon @ hostname colon 1521 /service, then slash of bracket complete, then another option tb db table comma table database name option user comma username option password comma password option driver comma oracle.jdbc driver oracle.jdbc.driver.oracle driver bracket complete, then option fetch size comma 5000 dot read. In our healthcare pipeline we use parallel JDBC read for ingestion large Oracle tables containing patient claims and prescription date efficiently. What is the difference between full load and incremental load? How do you implement watermarking? Full load read all data, all records from the source and overwrite the target. Simple but expensive for large table. Incremental use watermark, max update TS from last successful run and the next run, fetch only record changed after the watermark. Read last watermark like last underscore run is equal to spark.sql in bracket select max of watermark from audit.pipeline run bracket complete dot collect bracket complete 0 in square bracket 0 square bracket complete square bracket 0 square bracket complete. So that maximum watermark timestamp will be stored in last underscore run variable, then fetch only new or new change records like df underscore incremental is equal to spark.read.jdbc in bracket url comma table comma predicted in bracket predicted is equal to update ts is greater than last run. My project, I implemented incremental load for all 10 million daily records pipeline. Full load data were only used for only first run or explicit backfill. We also use another watermark approach for CSV file ingestion. For For live-based ingestion, we store the last processing time file timestamp in S3 Parquet metadata file. During the next run, Spark read only file that timestamp greater than the stored watermark. After successful ingestion, we override the metadata Parquet with new current timestamp. This helps us avoid reprocessing old file and made ingestion highly efficient for large daily file drops. Watermark based implementation is equal to process only what changed, essential for high volume daily pipeline. Note: don't use limit or date filter in SQL for incremental logic. Use persistent watermark storage in auditable, reliable and reusable, restartable. 59 question number: how do you integrate with Salesforce and Smartsheet API? I use Salesforce REST API and Smartsheet SDK in Python. For Salesforce, I authenticated using auth to client credential and query object using SOQL. And for Smartsheet, I use their official Python JSDK with API token stored in Azure Key Vault. The main challenges were first, pagination. Both API return data in pages of 200 to 500 records. I build a loop for fetch pages until no next page token is returned. Second, rate limit. Salesforce heavily API customer. I added exponential back of retry logic. If I get 459, wait 2 seconds, retry, double wait on next failure. Third, schema rip. Salesforce object occasionally add new field added. I handle this using Murray schema is equal to true while writing into Iceberg, so new fields are captured without pipeline failure. Salesforce for Smartsheet is equal to OAuth. OAuth2 pagination fetch explanatory. Note: don't hardcode API token, always put from key vault at runtime. First, here we are using request module and time module. First, Salesforce authentication. Auth underscore response is equal to request dot post in bracket authentication URL data is equal to in dictionary. Grant type is colon password, client ID colon client ID, client secret colon client secret, user colon user, password colon password, bracket complete, means curly brace is complete and bracket complete post. So then we have to auth underscore data is equal to auth underscore response dot JSON. Then we got the JSON. After that we have to take the access token and instance URL from response, like access token is equal to auth underscore data square bracket access token, instance URL is equal to auth underscore data in bracket instance underscore URL. Step 2, prepare the header. Header is equal to in dictionary authentication colon bearer access token comma content dash type colon application slash JSON. Third step is Salesforce pagination API with retry logic. You have to retry the logic for each page. This is the code. The summary: this code is first authenticated with Salesforce URL auth and generate the access token. Then it uses that token to call Salesforce REST API and fetch account data. The function also handles pagination, meaning Salesforce rerun data in multiple pages. It automatically fetch all records. It also includes retry logic for API failure or rate limit, making the pagination process reliable for large-scale pipeline. 16 question: what is idempotency in pipeline? Idempotency in pipeline. Idempotency means rerun the pipeline does not create duplicate records or wrong result. three pattern I use: merge into instead of insert, override pattern, and deduplication before write. Merge into instead of insert means handle rerun gracefully by updating existing record rather than duplicating. Override partition means override only specific data partition being reprocessed. In my project, all my Icebug injection use merge. So if any EDF trigger file the job twice due to retry, the second run it is a no op for unchangeable record. Merge syntax is like uh, delta table dot alias t dot merge in bracket df underscore source dot alias yes comma t dot record id is equal to yes dot record id bracket complete dot when when matched update all bracket complete dot when not matched insert all bracket complete dot execute bracket complete. Replace with override only one partition. df dot write dot format in bracket delta dot option replace where comma load date is equal to 2024 01 15 more overwrite dot save path. Next question is, how did you achieve 99.9% uptime for 10 millions plus record daily? 99.9 uptime means less than 9 hours. 99.9% uptime means less than 9 hours of downtime per year. It achieved this through four practices. First, implement idempotent pipelines. Every run use merge so retry are fast. ADF auto trigger failed job up to 3 times. Second, audit logging with Molek Nabu. For every run I write a rows underscore read, rows underscore write status and timestamp to audit table. If something goes wrong, I can pinpoint exactly which run and which store records were affected. Third, error handling and quarantine. Bad records does not fail the pipeline. They go to the quarantine bed table with the failure reason. Good records continue processing. Fourth, event-based trigger. Instead of fixing time schedule, I use ADLS event trigger for file-based storage. Pipeline fire only when the file actually arrive. No wasted run or missing file. Together, those means failure are catch stay fast, retry are safe, and bad data never book good data. 99.9% uptime is equal to abundant pipeline plus audit logging plus quarantine pattern plus event based trigger. Note: don't rely on schedule based trigger for file based sources. If the file is late, the pipeline runs on nothing. Use event based trigger instead. How do you design pipeline for exact one symmetric? Exactly once means how question again. I will repeat the question. How do you define design pipeline for exactly one symmetric? Exactly one means every record is processed and written exactly one time, not 0 times, not twice. For batch pipeline, I achieve this with two things: persist watermark, so we fetch the same record on retry, and merge into target, so duplicate record are deduplicated at write time. Even if the pipeline runs twice for the same window, the result is indicated identical. For streaming pipeline like Kafka to Delta, exactly once needed three things together. First Kafka customer offsets committed only after successful write. Second, checkpoint location on S3 so Spark knows the last processed offset. Third, merge in fetch for each batch so reprocessed batch does not create duplicate. Checkpoint track the note. Checkpoint alone does not give exactly once. If you use mode append, you need merge to handle duplicate for replay batches. Now we talk about some SQL question. Window function versus aggregate function. Aggregate functions like sum or count with group by collapse all rows in groups into the same one result. Basically, aggregate function like sum, count, average, mean, max with group by collapse all rows into one result row. Window function compute the same aggregation but keep every row. Each row get the aggregated value alongside its original date. I use window function heavily in every pipeline for deduplication, row number, running total, or identifying the last record per entity. Don't confuse partition by in window functions with table partitioning. They are completely different concept. One for actual syntax, another is physical storage. Second, row number versus rank number versus days rank. Row number is equal to unique. Row number is always unique. Rank gaps after tie, and days rank is no gaps after tie. Given score 10, 10, 100, 100, 90, 99. Row number will be like 1, 2, 3, 4. Rank 1, 1, 3, 4. Days rank 1, 1, 2, 3. If I use row number for deduplication, pick exactly one row per key. Rank and days rank for business ranking report whether tie matter. Optimize slow SQL query with large table join. My approach is to slow SQL. First, I run explain, find the most expensive operation, full scan, nested loop in. Second, push filter early, filter before joining, not after. Avoid select star, read only needed columns. Replace the correlated subquery with joins. Correlated subquery run one for row. Check join order. Join smaller filtered table first. Partition pruning. Ensure filters on partition column are used. In my project, I focused on query doing correlated subquery inside a loop. Replace with it pre-aggregated subquery join. Dropped runtime from 45 minutes to 4 minutes. Note: don't add indexing blindly. In OLAP, means analytical system like Iceberg or Delta, indexes rarely exist. Use partitioning and data skipping instead. Convert correlated subquery to join. Correlated subquery run one per row. Time period like O of n square. Performance. Replace with pre-aggregated subquery.